yesterday we are talking about synchronous counter, and we saw how synchronous counter can be designed for 3 bits synchronous counter, and we were discussing about the possible design for 4-bit synchronous counter, up counter or down counter. So among between up counter or down counter, we'll try to design one today for the 4-bit synchronous counter. So which one I should design, up counter or down counter? Tell me.
Counter.
Which one?
Up counter.
Say up count.
Okay. So it says 4-bit synchronous counter, and now we are doing the up counter. So up counter 4-bit means, as I said before, for each bit you need to have a flip-flop. So 4-bit synchronous counter means you need
4 flip-flops.
So it should be Q3, Q2, Q1, Q0. That defines my present state. And then you will have Q3 plus, Q2 plus, Q1 plus, and then Q0 plus. That should be my next step. And for Q2 you should have J3 K3, then you should have J2 K2 for Q2, then you have J1 K1 for Q1, and then finally J0 K0 for Q0. So now for my first case, since we have 4 counters, so there will be 16 states. So 0 0 0, then 0 0 0 1, then 0 0 1 0, then 0 0 1 1, then 0 1 0 0, then 0 1 0 1, then 0 1 1 0, then 0 1 1 1, then 1 0 0 0, then 1 0 0 1, then 1 0 1 0, then 1 0 1 1. Finally 1 1 0 0 1 1 0 1 1 1 1 0, and finally 1 1 1 1. These are the 16 states. And now if we are considering the up counter, then the next state would be 0 0 0 1, right? After 0 it should come 1. After 1 it should be 0 0 1 0, which is 2. After 2 it should be 3. After 3 it should be 4. After 4 it should be 5. After 5 it should be 6. After 6 it should be 7. After 7 it should be 8. After 8 it should be 9. After 9 it should be 10. After 10 it should be 11. After 11 it should be 12. After 12 it should be 13. After 13 it should be 14. After 14 it should be 15, and after 15 it should return back to 0, right? So now if we consider Q3, and if we compare that with Q3 plus all the values given here, so let's see how we should put J3 and K3. So 0 0 means no change. So for no change it should be 0 0. Then 0 0 again no change, so it should be 0 0. 0 0 no change, so it should be again 0 0. 0 0 means no change, so it should be again 0 0. 0 0 no change, so it should be again 0 0. 0 0 means no change, so it should be 0 0. 0 0 means no change, so it should be again 0 0. And then 0 1, it means it is changing, so it should be in toggle mode, so it should be 1 1. Then again 1 1 means no change, it should be 0 0. 1 1 means no change, so it should be 0 0. 1 1 means no change, so it should be 0 0. 1 1 means no change, so it should be 0 0. 1 1 means no change, so it should be 0 0. 1 1 no change, so it should be 0 0. 1 1 means no change, so it should be 0 0, and finally 1 0, so state is changing, so it should be in toggle mode. So is there any confusion so far? We have done
No,
all
sir.
yesterday, right?
Yes, sir.
Yes, sir.
So now we are comparing Q2 and Q2 plus. So now 0 0 means no change, 0 0 means no change, 0 0 means no change, 0 1 means change, so it should be in toggle mode. Then 1 1 again no change, then 1 1 again no change, then 1 1 again no change, then 1 0 means it's changing. So if you see, after 3 zeros, here comes the toggle. So for the rest of the scenario, we can do after 3 0 it should be 1 1, again after 3 0 it should be 1 1. So you can check it by yourself, right?
Yes, sir.
In the exam you should always check each and every state, because you need to be sure whether you are doing it right or not. So so now if I consider my Q1 and Q1 plus, then 0 0 means no change, 0 1 means change, 1 1 means no change, 1 0 means change, 0 0 means no change, 0 1 means change, 1 1 means no change, 1 0 means change, 0 0 means no change, 0 1 means change. So all the way you can do like this. You can verify it later on when you will be doing by yourself. So similarly, for the last part, we can consider Q0, compare the result with Q0 and Q0 plus, and you can see 0 to 1 means state change, 1 0 means state change, 0 1 means state change. So all the way it will be 1 1. You got my point, right?
Yes, sir.
Any confusion so far?
No, sir.
So now if I do the K-map, for J3 and K3, since both has the same input, so I can do one K-map for both inputs, and my input should be Q3 Q2 along this side and Q1 Q0 along this side. So it should be 0 0 0 1 1 1 1 0, and here it should be 0 0 0 1 1 1 1 0. So for the first 4 cases it's 0, then next 4 cases 0 0 0 1 here, then again for the next 4 cases it is 0, and then for the next 4 cases it is 0 0 0 1. So if you combine them together, what should be the value of J3 and K3? It should be between these two rows, what is in common? Q2, right?
Yes, sir.
And between column it should be
Q1 and
1
Q0.
Q0.
Q0, right?
Yes, sir.
So now if I try to do the KMF for J2 K2, so now what should I put? 0 0 0 1 0 0 0 1, then again 0 0 0 0 0 1, then again 0 0 0 1, and finally again 0 0 0 1. So how can I combine them? We can take these four in a group, right?
Yes, sir.
So what should be J2 K2?
Q1, Q0.
Q1
Q0.
Q0, right?
Yes, sir.
Now if I do the KBF, so now it's J2 K2. Suppose this is Q3 Q2 along this direction 0 0 0 1 1 1 1 0, and then Q1 Q0 along this direction, so it should be 0 0 0 1 1 1 1 0. So now here 0 1 0 1 means 0 1 0 1, then again 0 1 0 1, so 0 1 0 1, then again 0 1 0 1, so 0 1 0 1, and finally 0 1 0 1. So how can we combine them? We can take these 8 ones in a group. So finally I can write, oh sorry, this should be J1 and K1, right? So J1 equals to K1 equals to, we can write what is common between these two columns?
Q0.
Q0. And finally if you see for J0 and K0, all the inputs are 1, so we can write J0 equals to K0 equals to
1.
right?
Yes, sir.
So now if I have 4 flip-flops, suppose this is J0 K0 and this is Q0 and Q0 bar, so we need to put same input clock pulse for each and every flip-flop. That's why it is called synchronous counter, right?
Yes, sir.
Now for J0 and K0, what should be my input? 1. So it should be 1. And since for this flip-flop there is no flip-flop on the left hand side, so we are only putting 1. Now if this is J1 and K1 and this is my output Q1 and Q1 bar, so for this flip-flop, how many flip-flops are on the left hand side?
1.
Right? And what is their output? Q0. So Q0 should come as the input for this flip-flop, which is this one, right? Now if you have J2 and K2 and then output is Q2 and Q2 bar, so for this flip-flop, how many flip-flops on the left hand side?
2.
And what are their outputs? Q0 and Q1.
Q1.
What we need to have a AND gate here, and this AND gate output will be connected to J2 and K2, and this input should be Q0 and
Q1.
right.
Yes, sir.
So for the last part, this is J3 and K3, and this is Q3 and Q3 bar. So for this flip-flop, how many flip-flops are on the left-hand side?
3.
3. So the output for this flip-flop should have 3, right?
Yes,
So
sir.
if you take one input here, so this will be Q0 and Q1, right? And then if you put the output from here, so output here should be Q0, Q1, Q2, right? Which is this one. Make sense?
Yes, sir.
So now, if you are asked to do the down counter, what you can do for the down counter? What will happen? Instead of the output, you need to
Take the bar.
have the complement of it, and it should be joining, connected together as same as the up counter, with the exception that instead of QA you are connecting QA prime, and you can do it from the KMF, right?
Yes, sir.
So is that any question so far, or anything that needs clarification? Can I go to the next slide?
Yes, sir.
Okay. So as you can see, what we have been doing here, it's given here. It's a up counter because the output is connected getting from A, B, C and D, not from the bar of itself. So it's a 4-bit
Up counter.
up counter. And since when you have the same input for J and K have the same input, so it will work as a T flip-flop, right? So instead of using a JK flip-flop, we can do the same thing with T flip-flop, right?
Yes, sir.
Yes, sir.
Okay. Now we have a synchronous decade counter. So decade counter means how many states you should have,
10.
10.
right? So it will start from 0, it will go all the way
9.
9. So for 10 states, how many flip-flop you should add? At least 4, right? So there will be 16 states, out of which you need from 0 to 9. So what are the states missing? 10, 11, 12, 13, 14, 15. So now you have to make an arrangement such that whenever this 10 is appearing, you can reset the whole system and it should go back to
0.
So how can we do that? So in order to make 10, if I say the input are arranged in this way, D, C, B, A, then how can I make 10? 1, 0, 1, 0, right? So which are the inputs? That should be 1, D and D. So here you can see B and D are ANDed together, and then whenever these two inputs are 1, the output should be 0, so that these all the flip-flops will get 0, and once it gets 0, it will reset, right?
Yes,
Yes,
sir.
sir.
Go back to 0. So now if you see the synchronous mode counter, mode 14 means how many states should be there?
14.
14. So it means from 0 to,
Yes, sir.
so which are the states is missing?
14.
Only 14.
14 and 15. So we have to make an arrangement such that whenever you get the 14, it will go back to
0.
0, right? So how we can make 14? So if you say DCBA, so how can we make 14? 1, so 8 plus 4 gives you 12. In order to make 14, you need to have 3 ones and then
0.
right?
Yes.
So what you need to do, D, C and B, whenever these 3 gets 1, then as you can see D, C, B, when all of them are 1, the output will be 0, and once this output will be 0, this will come here and it will reset the system. You got my point, right?
Yes.
Yes, sir.
Yes, sir.
Is there any question so far?
No, sir.
Yes, sir.
Okay. So now, as we have been saying, so whenever, suppose this is a up-down counter, so it means whenever your input is 1, it will always count up, and whenever your input is 0, it will count down. So likewise, as you can say, it's a 3-bit counter, so there will be 3 flip-flops, A, B and C. So for up and down counter, for both cases, the least significant bit, its input will be always connected to 1, right? So we don't need to think about that. We can always have the least significant bit flip-flop inputs connected to 1. But we have to be concerned about the rest of the flip-flops, right?
Yes, sir.
So whenever we are thinking about this flip-flop, how many flip-flops on the right hand side?
1.
Right? So here your input should be 1, A, if you want to have a up counter, or A bar when you need to have a
Down counter.
counter, right?
Yes, sir.
Similarly, if you are considering this flip-flop, how many flip-flops are on the right hand side? 2.
2.
So it can have either AB input for the up counter or A bar, B bar for the down counter, right?
Yes, sir.
Yes, sir.
So for this case, suppose this is my YB and this is output here is my YC. So for YB, what I need to do? So suppose we are considering about a control command M such that the YB, when this is 0, it means it will count downwards. So it will be down counter. So in order to have down counter, what we need to have?
A bar.
A bar, right? And when it is 1, it will count up. So for up counter, it should be A, right?
Yes, sir.
Now, if we want to have a equation for YB, what it should be? So M bar when it is 0 and output should be A bar, plus when M is 1, meaning M, then output should be A, right? So as you can see, if you consider this to be M is directly connected here, and after NOT gate, here M bar is connected here. So output of 3, it should be M bar, A bar, and output of 1, it is MA, right? So here you can get MA plus M bar, A bar, right?
X naught.
Right?
Yes, sir.
Or what you can do, you can, instead of this circuit, you can use a XNOR gate, right?
Yes, sir.
Similarly, for this YC, what you need to do when you have M and YC as the output, so when M is 0, it should count down.
Counter.
So input should be
A
A
bar.
bar, B bar.
A bar, B bar, and when it is 1, it should count up, so it should be AB, right?
Yes.
So your equation YC, it should be M bar, A bar, B bar plus M,
B.
right?
Yes, sir.
Which is this circuit. If you see here, M is here and M bar is here. So here it should be M bar, B bar, A bar, and here it is M, A, B, right? So why it will be exactly as it is shown here. You understand my point, right?
Yes, sir.
Yes, sir.
So here we can have a up count, up down counter together. So now here it says you need to design a BCD counter using T flip flop. T flip flop. So how can you do that? So for BCD counter, how many bits should be there?
4 bits, sir.
4 bits. So 4 bits means 4 bits means 4 bits means how many counters should be there? 4, right? 4 flip flops should be there, right?
Yes, sir.
So as you can see, there are 4 flip flops. So what is meant by Q8? Q8 means here the power is 2 to the power 3. So it is the most significant bit, right?
Yes, sir.
And this should be
Least
the
significant.
least significant bit, right?
Yes, sir.
So if this is the present state, the next state we can write it as plus, right? So we indicate the next state, right?
Yes, sir.
So now for BCD counter, you can have 0 to 9, right?
Yes, sir.
But you cannot have 10 to
15.
15, right?
Yes, sir.
Whenever you have 4 bits, so how many states you can have? 0 to 15, right?
Yes,
Yes,
sir.
sir.
So from 10 to 15, it should be don't care, right?
Yes, sir.
Not be in use, right?
Yes, sir.
So whenever you have 0, the next state should be 1, right?
Yes, sir.
When you have 1, the next state should be
2.
whenever you have 2, next state should be 3. Whenever you have 3, next state should be 4. And whenever you have 9, the next state should be 0.
0.
Yes, sir.
Yes, sir.
Okay.
স্যার লাস্টেরটা বুঝলাম না যখন 9 থাকবে তখন নেক্সট স্টেটের লাস্টেরটা কি হবে
It should go to 0, right? Because for BCD counter, you can have from 0 to 9, right? So after 9, it should come back to 0, right? Because for BCD,
ইয়েস স্যার
there is no single bit digit left, right?
ইয়েস
So from here, as you can see, 1 0 1 0 to all the way 1 1 1 1, it will be don't care position for all, right? Because it will not be in use. So what is the truth table for T flip flop? The
If
truth
if
table
it
for
is
T flip flop is whenever you give 0,
same,
the condition will be
no
no change,
change.
right?
Yes, sir.
And whenever you give 1, the
Complement.
output will be in toggle mode, right?
Yes, sir.
So now if we consider Q8 position with the Q8 plus, so here 0 0 means no change, so input should be 0. 0 0 means no change, so input should be 0. 0 0 means no change, so input should be 0. 0 0 means no change, so input should be 0. 0 0 means no change, so input should be 0. 0 0 means no change, so input should be 0. 0 0 again, no change, input is 0. 0 1, so state is changing, so it should be in toggle mode, so input should be 1. 1 1 means no change, so input should be 0. And 1 0 means state change, so it should be in toggle mode, right?
Yes,
Yes,
sir.
sir.
So similar way, you can compare each bits and you can have this table, right? Do I need to explain that?
No, sir.
So now if I do the K map for T8, the input here should be Q8, Q4 here. Along this direction, it should be 0, 0, 0, 1, 1, 1, 1, 0. And then here it should be Q2, Q1 along this side. So it should be 0, 0, 0, 1, 1, 1, 1, 0. So as you can see, the first 4 bit, it should be 0, right? And then the second 4 bit, it should be 0, 0, 0, 1. And then it should be 0, 1, 0, 1, and the rest of the bit should be don't care, right?
Yes, sir.
How can we combine them? We can take these 4 in a group, right?
Yes, sir.
We can take these 2 in a group. So what will be the equation for TQ8 then? If you take this 4, what is common between these 2 rows?
Q3.
Q3.
Q8, right?
Yes, sir.
And between these 2 rows, what is in common,
Q1.
right?
Yes, sir.
And then if you take these 2, what is common between these 2 rows?
Q4.
Q4. And column wise it was
Q1, Q2.
Q2, Q1, right?
Yes,
Which
sir.
is this equation, right?
Yes, sir.
So now if we want to draw the K map for TQ4, so now for the first 4 bit, it should be 0, 0, 0, 1. Then for the next 4 bit, 0, 0, 0, 1. And then again 0, 0. And then rest of the inputs should be
Okay.
here, right?
Yes, sir.
So now how you can combine them?
Vertically.
You can take these 4 in a group, right?
Yes, sir.
So my TQ4 is
Q2, Q1.
Q2, Q1, right?
Yes, sir.
So this is this one. Now, as you can see, the last one is all the way 1, so it should be 1, right?
Yes, sir.
So we just need to do K map for TQ2.
Yes, sir.
So Q8, Q4 along this direction, and Q2, Q1 along this direction. So 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So now 0, 1, 0, 1. So 0, 1, 0, 1. Again 0, 1, 0, 1. So 0, 1, 0, 1. Then 0, 0. So 0, 0. And then rest of the value will be don't care, right?
Yes.
How we can combine them?
Q3 bar. Q8 bar. Q1.
So we can have only these 4 because we cannot take 8 common, right?
Yes, sir.
So for this 4, what is common between these two rows?
Q8 bar.
Q8 bar.
Q8 bar, right?
Yes.
And what is common between these two columns?
Q1.
Q1. This is this one, right? You got my point, right?
Yes, sir.
স্যার এখানে অলওয়েজ Q8 Q4 Q1 Q2 কেন হইতেছে?
This is done, or it done to means Q8 means here 8 means 2 to the power cube, right? So it is representing that it has a position value of 8, or you don't need to do this, you can simply do what we used to do: Q3, Q2, Q1 and Q0. Okay,
Yes.
it can be done this way. We are just following the books um,
নো
represent.
আই মিন স্যার কে ম্যাপে হচ্ছে এভাবে আমরা Q1 Q2 এই পাশে আর Q4 Q8 নিচ্ছি এভরি কে ম্যাপের জন্য, ওইটা কেন?
Because when we are writing here, so this is the most significant bit, right?
ইয়েস স্যার.
And this is the least significant bit, right?
ইয়েস
Yes,
স্যার.
sir.
So the most significant bit we are putting here row wise, and the less significant bit we are putting that in column wise. That's what we did for the KMF, right?
ইয়েস স্যার.
Now you got my point.
ইয়েস স্যার.
Any other questions?
নো কোয়েশ্চেন স্যার.
Okay. So now, what we have learned so far, we learned to design counter that doesn't have any states missing. So whenever you have 0, you can go either to 1 or 15, or from 1 to 2 or 0. So no state is missing, right?
Yes, sir.
So now we will try to design a counter that has some states missing. For example, you have a counter which has 0 state, 1 state, 2 state, 3 state, 4 state, and then 5, 6, 7 are missing. So here, as you can see, if this is from 0 to 4, 0, 1, 2, 3, 4, the next stage is 1, 2, 3, 4, 0. So for 5, 6, 7, it is not in the counter. So what we can do, we can either choose the don't care condition, or in this figure what they say, whenever you have 5, it should go to 3. Whenever you have 6, it should go to 2. And whenever you have 7, it should go to 1. So in that way, as you can see, when it is 5, it is going back to 3, right? Whenever it is 6, it is going back to 2. And whenever it is 7, it is going back to 1. So once we have the present state and next state, we can have the control command, right? We know how to do it. Is there any question? Any question?
No, sir.
Okay. So now, here it is said that you need to design this counter, this type of counter, using a D flip-flop. So what is the truth table for D flip-flop? Whenever you have positive edge or negative edge, and whatever you put it as a input, you will get the
Output.
like that, right?
Yes, sir.
So here, if the state is 0, next state is 1. If the state is 1, next state is 2. When the state is 2, next state is 3. And all the way, when it is 7, it is going back to 0. So it is working as a up, right?
Yes, sir.
Now we need to design that with the D flip-flop. So when you have this table, so we just need to compare C with the C plus. But for D flip-flop, what is interesting is that you always need to see what is in the next state, because if you need 0, your input should be 0. When you need 1, your input should be 1, because for D flip-flop, whatever you put as a input, this will come as a output.
Yes, sir.
Yes, sir.
So for D flip-flop, if you are given D flip-flop, so you should be happy that you don't need to compare the present state with the next state. Whatever is in the next state, you can put it as a input, right? So whenever you need 1, you should put 1. Whenever you need 1, whenever you need 0, you should put 0. You got my point, right?
Yes, sir.
So now, should I do the K-map or you can do it by yourself?
We can do, sir.
Okay, so this will be your homework. Let's go to the next step. So, the same flip-flop, you are asked to design with the T flip-flop. So, for T flip-flop, what is the truth table? You can have TC, TB and TA, right? So, for the T flip-flop, whenever you give input 0, the output will be no change. Whenever you give 1, the output will be the complement of the previous state, right?
Yes,
So
sir.
for
Yes,
T
sir.
flip-flop, we need to compare
Go
between
on.
the present state and the next state, right? We don't have the luxury like when we have the,
T flip-flop.
right?
Yes, sir.
So whenever you need to compare, then I am just doing for one cases. So suppose this is C plus, so whenever is 0, 0 means no change, it should be 0. 0, 0 means no change, it should be 0. 0, 0 means no change, so it should be 0. 0, 1 should be changed, so it should be 1. 1, 1 means no change, so it should be 0. 1, 1 means no change, so it should be 0. 1, 1 means no change, so it should be 0. 1, 0 means change, so it should be 1. So similar way you can have that table and then you can do the K-map, right?
Yes, sir.
Yes, sir.
So do I need to do further or I can go to the next slide?
So
You
we
have to
have
go to the next slide.
so we have to also design the circuit using T flip-flop, no, sir?
Right.
Yes, sir.
So should I do more or I can go to the next slide?
Next slide, sir.
Okay, so that will be your homework. And then if you have any problem, we can discuss it on the class, in the class. Now, I will try to explain that to you, this thing, and then I will conclude my class today. Because these are the things that we will be using for our flip-flop designs for the class tomorrow. Okay.
Yes, sir.
Suppose you have been asked to design a flip-flop, suppose from 0, then 1, then 2, then 3, then 4, and then it will go back to 0. So you are not using 5, 6 and 7. So either you can have this 5, 6, 7 for don't care condition, or you can put this back to 0. So when you need to use this JK flip-flop, So now what we are doing, we are not using the same input for J and K. So if you don't use the same input for J and K, then how we can do that? So here you see the first condition is when you need to transit from 0 to 0. So 0 to 0 means the state is changing or not changing?
Not changing.
Not changing.
Not changing. So what should be the condition for no change?
0.
J is 0 and K is 0, right?
Yes,
So
sir.
if I take J and K here, so from 0 to 0, it should be J 0 and K 0, right?
Yes, sir.
What we can do here, whether we have 0, we need to go to 0. So here, as you can see, if we also put 0, 1, the output will be 0, right?
Yes, sir.
So for this condition, what we can write, it can be 0 and K can be 1, right? So if we combine both condition, can you see what we can conclude? So J value should always be 0 and K value, it can be either 0 or 1, right? So we can say J value should be 0, K value can be don't care, right? So here it is showing like that. So if my present state is 0 and next state is 0, so we can use these two inputs. You got my point, right?
Yes, sir.
স্যার আরেকবার লিখবেন
Yeah, sure. Anyway, we need to go to 0. That is my aim. So how we can do that? If my previous state is 0 and now we need to go to 0, so we can use this condition. What does it means? We don't change the state.
ইয়েস
So
স্যার
for this no change condition, what we can put as input? 0, 0, right?
ইয়েস স্যার
Yes. Or we can do whatever is my previous input. If you put 0, 1, the output will always be
0 ইয়েস
So
স্যার
here we can also do 0, 1. So these two combination is possible for having the last state as 0.
ইয়েস স্যার
So now if we combine them together, as you can see, for both cases, J's value should be 0, where we have the freedom to choose any value for K, right?
ইয়েস স্যার
So that's why we are saying J's value should be 0 and K's value can be don't care.
জি স্যার বুঝতে পারছি
Okay. So if I do the next stage,
0, 1.
so now it is 0 to 1. So 0 to 1 means my state is changing, right?
Yes, sir.
So we should go to the toggle mode first. So for toggle mode, what should be the value of J and K? 1, 1, right?
Yes, sir.
Now, whatever is my previous state, if you always want to have the next state as 1, what should you do?
0.
You should have
1, 0.
1, 0, right? To
Yes,
have
sir.
the next state 1, right?
Yes, sir.
0. So from that one, what we can conclude, my J's value should be 1 and my K's value should be either 0 or 1, right? So we can say K's value can be don't care, right?
Yes, sir.
0 to 1, as you can see, my J's value should be 1 and my K's value should be don't care, right?
Yes, sir.
So now, if I try to conclude the third cases, which is 1 to 0. So 1 to 0, it means it is changing or not changing?
Changing.
Changing. So toggle mode should be choice. So input should be 1 1, right?
Yes, sir.
Sir.
Or whatever is my present state, if I want to have 0 as my next stage, so what should I choose?
0 1.
1.
0 1, right? 0 1. So if I put 0 1 here, now you can conclude my j's value should be, can be either 0 1 1, so it should be don't care, right? And k's value should always be 1, right?
Yes, sir.
So as you can see, for the third cases, j's value can be don't care, but k's value should be 1, right?
Yes, sir.
And now look for the, we'll try to solve the last condition, which is
1 1.
1 1.
Okay, 1 1.
So 1 to 1 means no change, right?
Yes, sir.
Condition should be
0 0.
0 0. And then whatever is my previous state, if you want to have 1 as my next stage, what should I put?
1 0.
1 0, right? 1 0. So from here, what you can see, in both cases, my k value should be 0, right? But for k, it can be either 0 or 1, so we can write it is a don't care, right?
Yes, sir.
Don't care, and k's value is 0. Is there any confusion so far? Any confusion?
No, sir.
Okay, so should I finish this today, or we can do it tomorrow in the class? Whatever you want. Should I do it?
Yes, sir, you can.
What about the others?
স্যার আপনার ইচ্ছা করান।
Okay, yes, let's do it. So now, here we need to remember this truth table. So I just need to copy so that we can put it here. Okay, so I just need to copy this table. Let's put it here. Okay, so here, as you can see, my state is 0 1 2 3 4 and then 0. What are the states that is not being used? 5 6 and 7, right?
Yes.
So they say whenever you have 5 6 and 7, it should go back to
0.
0, right?
Yes, sir.
So now, as you can see, when it is 0, so 0 is my present state, so my next state should be
1.
right.
Yes, sir.
When it is 1, my next state should be
2.
2. When it is 2, my next state should be
3.
3, right? When it is 3, my next state should be 4, right? When it is 4, my next state should be
0.
0.
0. When it is 5, my next state should be 0. When it is 6, my next state should be 0. And when it is 7, my next stage should be 0. If this 3 is not given, then we can put it as don't care, right?
Yes, sir.
It is not in use. So now, likewise, we did previously, what we need to do? We need to compare present state with the
Next.
state, right?
Yes, sir.
So now if we compare C with C bar, so now it is 0 to 0. So when you have 0 to 0, what should be your JK input?
No change.
If
0,
we are
don't
considering
care.
the different inputs, so it should be 0 and
Don't care.
right.
Yes, sir.
So when it is 0 and 0, it should be again 0 and don't care. When it is 0 and 0, it should be again 0 and don't care. When it is 0 to 1, when you have 0 to 1, it should be
1 and don't care.
and don't care, right?
Yes, sir.
Then when it is 1 to 0, it should be
Don't
1
care. 1.
don't care 1, right?
Yes, sir.
1 to 0, it should be don't care 1. 1 to 0, it should be don't care 1. 1 to 0, it should be don't care 1. You got my point, right?
Yes, sir.
Then we need to compare B with B plus. So if we are considering B with B plus, then what we can do? B 0 0 means 0 don't care. 0 1, 0 1 means 1 don't care. Then 1 1 means don't care 0. 1 0 means don't care 1. Then 0 0 means again 0 don't care. 0 0 means 0 don't care. 1 0 means don't care 1, and 1 0 means again don't care 1. You got my point, right?
Yes, sir.
Yes, sir.
So finally, when you are comparing A to A bar, so 0 1 0 1 means
1 don't care.
then 1 0 means don't care 1. 0 1 means 1 don't care. 1 0 means don't care 1. 0 1 means 0 to 1 means, sorry, 0 to 0. 0 to 0 means 0 don't
0, don't care.
1 0 means don't care 1. 0 0 means 0 don't care, and 1 0 means don't care 1. So you understand, right, how this is happening?
Yes, sir.
Sir.
Since both inputs are different now, so we need to have K maps for each and every inputs, right?
Yes, sir.
So if I try to draw the, oh sorry, it's a 3 input one. It should be 3 input one. So for JC, it should be CB along this side, and A should be along this side 0 1. It should be 0 0 0 1 1 1 1 0. So now if we consider the first 4 here, so 0 0 0 then 1, and rest 4 it should be don't care. So how we can combine them?
2 1s.
We can take these two, right?
Yes, sir.
So what should be my JC? JC should be
AB.
have B, and here you can have A, B, right?
Yes,
Yes.
sir.
And for KC, we can have say B and A, 0 1 0 0 0 1 1 1 1 0. So here you can see for first 4 it should be don't care, and for the last 4 it should be
1 1
1. So how we can combine them?
All 8.
1.
We can take 8 1s together, right? So
Yes.
my
Yes, sir.
KC can be 1, right?
Yes, sir.
Yes, sir.
So now if I want to have a K-map for JB, so now for JB it should be 0 1 0 1 don't care, and then
Sir, 1. Sir,
0 0 don't care.
sir 1 then 9.
Oh, sorry, 0 1 here, right?
Yes, sir.
Don't care, and then 0 0 don't care. So how we can combine them? We can take these two, right? So my JB should be C bar A, right?
Yes, sir.
And my KB KB, so if I put CB along this direction and A along this direction, 0 1 0 0 0 1 1 1 1 0. So for KB it should be don't care 0 1. So don't care 0 1, and then don't care 1 1. So don't care 1 1. So how we can do that?
Lower 4 and column 1 4.
So we can take these 4 as a group and these 4 as a group, right?
Yes,
Yes,
sir.
sir.
So my KB should be, if we take these two common, then it should be
C. Yes, sir.
and here it should be nothing, so it should be C plus. If you take this 4 common, it should be
A.
right.
Yes, sir.
Now the last one, it's JA. So if I do the MF for JA, so it can be JA. So CB along this direction and A along this direction, 0 1. So 0 0 0 1 1 1 1 0. So here as you can see, for the first 4, 1 don't care, then here 0 don't care, and then again 0 don't care. So how we can combine them? We can take
Upper 4.
first 4, right?
Yes,
Yes,
sir.
sir.
So it can be JA is,
C bar.
it should be C bar, right? And for the last case, KA zero 1. So 0 0 0 1 1 1 1 0. So here you can say don't care 1, and then don't care 1, So it should be
A. 1.
you
1,
can take
sir. 1.
8 ones in a group, right?
Yes, sir.
Yes, sir.
So now what should be my circuit? So if I draw the 3 flip-flops, I should have the same clock pulse for each and every flip-flops.
Synchronous.
Now, suppose we are considering this is JA, KA, and this is my output QA. This output should go as the output. So for JA, what should be my input?
C bar, sir.
It should be C bar, right?
Yes, sir.
And for KA, it should be
1.
Again, now it is JB and KB. Here you should have QB and QB bar. Here I should write QA bar. So QB should go in the output. So for my JB, what should my input?
C bar A.
And
So
gate.
it should be a AND gate.
Yes, sir.
Here it should be C bar and A. It should go as JB, right?
Yes, sir.
And for KB,
C plus A.
be
OR
a
gate.
OR gate, right?
Yes, sir.
And here it should be
C
A
and
and C, right?
Yes, sir.
yes, sir.
Okay. And now for the last one, if I consider this to be output, this should be QC and QC bar, and here it should be
JC.
C and KC. So for KC, it should be
1.
1
1. And for my JC,
BA.
it should be a
and gate.
AND gate, right?
Yes, sir.
And input should be A
With
and
B.
B. This should be the counter circuit for to have this specific sequence of digits, right?
Yes, sir.
Yes, sir.
So any confusion so far? Any confusion? Oh, can I do this here? Okay, so today we are done now. So tomorrow I will upload this class lecture within couple of minutes. So you just go through it. If you have any question, you can ask me tomorrow. And then we'll start from the next slide, okay?
Yes, sir.
Okay, sir.